Now let's talk about the speed and velocity of Mr. Blue. If you want to know how fast an object is or how slow an object is, you consider how much distance the object covers in a particular time. For instance, if you and your brother or sister are to cover a distance of 10 kilometers, if you use 1 hour to cover that distance and your brother or sister used 30 minutes to cover the same distance, who amongst you is fast? So how fast you are is determined by how much distance you cover per unit time. So we say that speed is the distance covered with respect to time, or speed is the rate at which you cover a distance in a given time. The same thing applies to velocity. Velocity is the rate at which your displacement changes with respect to time. But what is the difference here? We already know the difference between distance and displacement. That one is done. But then what difference can we strike out here? Let's discuss this diagram. Now let's come here first. This guy start from this point and then travel to point A. He used 5 seconds to travel from his original position to point A. He used the same 5 seconds here, 5 seconds, and then here he used 10 seconds to complete this journey. Now, if you want to know the speed of this guy from the start to point A, we divide the distance he covered. So his speed is equal to the distance he covered, which is 10 meters, divided by the time he used to cover that distance, which is 5 seconds. So this will give us his speed to be 2 meter per second, or 2 meter per second. So 2 meter over 1 second. So this is telling us that every 1 second he covers a distance of 2 meters. So every 1 second he covers a distance of 2 meters. The next second he covers 4, 6 onwards. So that is what speed means. Now with velocity, it's the same thing. His velocity, you remember his displacement when he's traveling this way, the displacement is the same as the speed. So the velocity here is also equal to 10 meters divided by 5 seconds, which is also giving us 2 meter per second. So you realize that the speed and the velocity are the same, but where does the difference comes in? The difference comes in where we have to show direction, because for speed we don't need to show any direction and it carries only positive value, but for velocity we need to show direction, and we show direction either by indicating sign, by showing whether it is positive or negative. In this case it is positive because it is moving in the right, and we've said that we are taking the right as our convention to be positive. So this speed, direction do not matter, but displacement, direction matters. Another way we can also show direction is to indicate what direction it is moving. For instance, 2 meters to the east, to the north, or to the west. So you can ignore the sign and indicate which direction it is moving, whether to the north, south, east, or west. So for velocity, direction is key, and speed, direction is not so much important. So just like the distance and displacement, this one too is the direction that strike the difference between them. So when we look at up here where Mr. Blue is having fun on an empty road, he travels in this direction and he travels with a speed of, let's say, 20 meter per second. It means that every second he covers a distance of 20 meters. Then he got to this point and continued his journey to the other end. And let's say here he continued with another 20 meter per second. Then he got here and descended with 20 meter per second. Now we say that the speed with which Mr. Blue travels from here to here is the same speed with which he travels from here to there, and is the same speed he travels from this point to that point. The reason being that for speed, direction is not important. So his speed is 20 meter per second, 20 meter per second, and 20 meter per second. But when we are talking about his velocity, we have to indicate which direction he's traveling in. For instance, here he's traveling 20 meters west, and here he's traveling 20 meters south. So basically this is the difference between speed and velocity. They are the same, only that for velocity, you have to indicate direction. So just as we did for distance and displacement, speed and velocity are also similar, or I can say they are the same, only that velocity is speed whose direction has been specified. So if you measure the speed of a moving car and you specify its direction, you are actually measuring the velocity of that car. Speed is equal to distance divided by time, and velocity equals displacement over time. You are also not wrong when you say velocity is equal to distance over time with a specified direction. So velocity can also be distance over time with a specified direction. So this is why in most of our works we see speed and velocity being used interchangeably, and with distance and displacement you notice that they are also used interchangeably because of the fact that they are also very similar. Now back to Mr. Blue. When you look at his speed or his velocity on this path, it's 20 meters per second. It's not changing. The speed or velocity on this path is 20 meters per second. It's not changing. And likewise, the speed or velocity here is 20 meters per second. It is not changing. Therefore, if you want to describe his motion in terms of whether he is speeding up or slowing down, you cannot say he's either slowing down, neither is he speeding up. Therefore, he is not accelerating. So anytime an object moves with an increasing velocity, we say he is accelerating. And when he is moving with a decreasing velocity with respect to time, we say he is decelerating. Deceleration or retardation, which is the same as negative acceleration. So the acceleration of a body is the rate at which velocity or speed changes with time. Acceleration is a vector quantity and therefore it is direction sensitive. Now let's first look at this guy on the track again. Assuming his velocity for this part of the journey is 2 meters per second as we calculated. Here was 2 meters per second, this side to 2 meters per second, and then here 2 meters per second. Now it is clear to us that his speed is not increasing, his speed is not decreasing. So he's moving with a constant speed or a constant velocity. So when speed or velocity is constant, acceleration is equal to 0. But if the object or the person starts from 0, he started with a speed of 0 meter per second, then his speed started increasing. He increased to 1 meter per second, then it continued increasing 2 meter per second, then at this point he's somewhere around 5 meter per second. Then when he gets here, he starts slowing down 4 meter per second, and then he's 2 meter per second, then at the end he's 0 again. Now what does this tell us? He started from 0, his speed is increasing. So from his starting point to C, we say that he is accelerating. His speed is increasing. So he is accelerating. So we have positive acceleration when speed is increasing. But from C getting to D, you notice that the speed starts to decrease. She starts to slow down. And then when you are slowing down, we say he has a negative acceleration. And negative acceleration, we mostly call it deceleration or retardation. The last quantity we can use to describe motion is time. Time is just the continuous progression of our existence, which is irreversible, measured with a watch or clock, and it is measured in seconds. Physics is basically the understanding of concepts and mathematics. We've talked a lot about the concept of describing motions in a straight line. Now we are going to look at the mathematics. So check my next videos for the formulas and worked examples as well as past questions on linear kinematics.